So our presenter today of Lagoon design using AutoCAD Civil 3D is Michelle Rasmussen. Michelle, the floor is yours.
Excellent. Well, welcome everyone. I'm excited to be able to share this with you. This actually comes from our Civil 3D grading manual, and I'm going to be focusing on Chapter 6 of that manual. So, oops, losing my earpiece, sorry about that. But you can actually follow along with this if you'd like. I'm going to be skipping some of the exercises, just kind of showing you the results because of time today. And basically, if you've been using Civil 3D for a while, you probably are already familiar with how to do some of the simpler tasks that I'll be skipping. But I'm going to focus a lot more attention on working with the complex grading object, which is going to be our corridor today. So just to let you know a little bit about what's covered, with the Civil 3D software, you're provided a lot of tools that create multiple design scenarios in compressed time. Another benefit of using Civil 3D is the ease of making changes to that design, and you can easily create finished ground surfaces in parcel lines, feature lines, and grading objects, which are covered in the first 5 chapters of the grading manual. But unfortunately, they don't provide the level of flexibility that many projects require. So as an alternative to grading tools, this chapter, Chapter 6, actually explores using the AutoCAD Civil 3D corridor as a grading tool. And the corridor and its tools provide easy design and editing tools. It is a very non-standard approach to grading using the Civil 3D software, but the corridor sub-assemblies provide more daylighting options than grading objects do, and we'll get into that a little bit later on. So starting out, we're going to talk a bit about alignments. Alignments can be used to create more than just rows. Using alignments instead of grading objects provides greater flexibility and ease in making design changes than grading objects and feature lines. So if I want to, change the shape of my grading object, it's very easy to do just by using grip edits or using the grid view of your alignment in Civil 3D. Grading solutions with alignments and corridor models do not have to be linear. They can be. A couple of linear grading objects used with corridors might be dams or levees, but the solution also can include enclosed areas such as parking lots, ponds, or lagoons. But when grading an enclosed area, there are just a few things that you need to keep in mind. So one thing you need to do is make sure that the endpoints of the enclosed areas are along a straight segment. You see, here's an alignment that I'm going to be using for a grading object. And my beginning station is at the same location as my ending station. And they're both along a straight line, so that the bearing is equal on each side. The reason for that, if I were to use, maybe say this line down here as my alignment, if I had started my beginning station at this point, what's going to happen is that when we get into doing the corridor model, the sub-assemblies or the assemblies are going to be applied to that alignment perpendicular to the alignment, right? Well, it's all fine and wonderful, especially, even on these corners over here, because it will transition between assemblies. But when we get back to the ending station, it doesn't know what you want to do in this area right here. So what happens is your contours will start at the beginning station and come all the way around, but then they'll end at the ending station, and again, you'll have this gap right here. And this is what we want to avoid. So there's a couple of things that you can do. One thing is you can actually use the transparent command, the bearing and distance command, to make sure that it starts and ends at the same bearing. Or one thing that I like to do, I like to cheat. And so I'll actually create a line in my drawing, and then I'll start my alignment at the midpoint of that line, go up to the end point, and then go ahead and create the alignment the rest of the way around. But when I come to end, the second to last point will be at the end point of the line, and then it will end at the midpoint again, so that we have a nice straight line, and we won't have any gaps between our beginning and ending stations. So the other thing that you need to do is, depending on the corner treatment that is required for your project, it's recommended that you include horizontal curves between the tangents. If you don't, you'll end up with slider projections as you see here. Basically, it will just go ahead and transition between the assembly before the corner and then the assembly after the corner. But you will get your contour lines in between there, so you won't have a problem. So if minor projections are okay, great. If you want a little bit more of a smooth transition, go ahead and put your curves in. Even if your curve is very, very small, it's going to give you a nice smooth transition around the corners. All right, so let me go out into the software and show you how that looks. Now, if you are new to the software, it should take you about 15 minutes to finish the first practice. I'm not going to spend that much time on it for time's sake. And plus, I'm already very familiar with the software and very familiar with the data set that I'll be showing you. So it's not necessary for me to take as much time. Let me go over here. What I have in my drawing is I have 3 polylines. 2 of them happen to be open polylines, as you can see here. And the third one is a closed polygon. Let me get rid of my quick tools here. When I look at this polyline, you'll notice that it has an endpoint right here in the center of the line. That's where I've gone in and I've used my straight line to create this segment across the top, making sure that my beginning and ending stations start and end at the same point along the same bearing. So when I'm ready to create that alignment, I just go in and create the alignments from my object. I'll select my polyline, and my direction I'm sure is fine. So I'll just give it a name. This is going to be my pond or lagoon, whichever you want to call it. And I need to make sure that the site is correct. The site is key because when you're working with alignments and corridors and feature lines and grading objects, if you have them all in the same site, they'll actually read each other. So later on, I'm going to add a weir right between 2 bays of this pond. So this will be my north bay and this will be my south bay. I'm going to add a weir right between them with feature lines. So just because I'm using corridor models to grade my pond, I don't have to exclusively use one tool or another. You can combine them together, okay? So I'll just go ahead and add some curves in there. And I do want to erase the existing entities, just keep my drawing clean, makes it look nice. Click OK, and voila, it's added my polyline, or it's added my alignment where my polyline once was. Now, typically when you're working with grading plans, you're not going to go along and station along the rim of your pond if you're doing grading. And you're probably not even going to care about these points of intersections either. Well, it's really easy to just come in and change that display by changing first the style of the alignment that you're working with. So I'm turning off this point of intersection, okay? And I can also go in and change the labels. In fact, I'm going to remove all of the labels by just going into the alignment labels, import the label set that I want. Whoops, onto my other string. There we go. I'm going to do no labels at all. I'll click OK, and now it's all cleaned up, ready for me to go on to the next one. I could have set this up so that my default would have been the style that I chose and the no labels that I chose, but I wanted you to see how to work with that. And instead of actually going through and showing you each and every one of those, I'm just going to jump to another drawing that has all of my alignments complete. You can see here's my my pond north bay alignment, my pond south bay alignment, and my outer rim. Now, all 3 of these are going to be combined together later on in one corridor model, so be ready for that. All right, let's go ahead and go back to our slides here. All right, so our alignment is done. Now we're ready to move on to creating profiles. So we're going to create profiles that are used in a grading solution. The process of creating a grading profile is very similar to creating a profile for a road design. The same tools are used, but different precautions are needed. So first off, if you need to make adjustments to the alignment. So maybe you need to, make a curve a little bit longer, or lengthen one of the tangents, something like that. What you need to be aware of is when you make changes, it's going to lengthen and shorten the profile as well. So you can see here is my profile view, and here's my finished ground. And, I'm sorry, this is the red line is my existing ground, and then I have my finished ground below it. And what I've done is I've extended my finished ground profile beyond my existing ground. That way, as I make adjustments to my alignment, I don't have to worry about anything being lost over here, because I don't know if you guys have ever seen this, but when you have a gap, so let's say my finished ground alignment actually ended back here, what's going to happen to your corridor? Well, it's not going to know what to do vertically right in this area where there's a gap. So what happens is it just jumps right down to elevation 0 and then jumps back up to where the beginning station was. And that can be a problem with the corridor. So here we're just extending that finished ground profile past our existing ground profile line so that we don't have an issue. And I typically recommend about, 200 feet or something like that, okay? Now the next thing that you need to be aware of is you need to make sure that you don't, if you're working in an enclosed area, right, your alignment is going to start at one point, go around, and it's going to end at one point, at the same point. So what's going to happen at this point vertically? Is it going to stay all the same elevation, or is it going to change elevation? Well, to make sure that you don't end up with a wall right there where those two pieces enclose at the beginning and ending point of your alignment, what you'll do is make sure that your beginning station of your profile and your ending station of your profile are the same elevation, all right? So let me actually go show that to you. I actually have a drawing that already has my profiles created. And there we go. And let me just show you the first one here. So this one is the south bay. You can see my finished ground goes straight across. Well, why? Because we're designing a pond, and the water line is going to be the same elevation all the way across there. So does it make any sense to have any vertical curves? Probably not. You can see that also it starts at the same elevation as it ends, and look at that. It goes beyond my existing ground profile so that if I lengthen that alignment, it's not a problem. Here, my pond north bay, it does have some transitions in it. So we're going to start at a certain elevation, come down just a little bit, go across, and then it's going to go right back up. But you'll notice right here, where I've had it end at the existing ground elevation, then I've gone and put it straight across there for my extra length. That way I make sure I end at the same elevation, even if that alignment gets lengthened. Now my outer rim, there's a lot more going on because I've got a road on one side, or whatever the case might be. So this is the outside of the pond, and so I do have a little bit of transition going on. But again, it starts at the same elevation as it ends, and it goes beyond my profile. Okay? So that's how you go ahead and create your profile. The next thing you need to do is you need to determine the best sub-assembly to use for the type of grading being created. So let's talk a little bit about some of the assemblies that you have available. First off is, if we were using grading objects, we would have 3 grading criteria that you could use. You have your grade to distance, your grade to a surface, and either a relative elevation or an actual elevation. And so the assemblies, the 3 assemblies that equal those would be the link, width, and slope, which would be grading to a distance, the link slope to a surface, which is equal to the grade to a surface, and then the link slope to elevation, which is either to an actual elevation or a relative elevation. You can set those elevations right in the assembly parameters as you're creating them. By the way, these sub-assemblies are all found on the generic tab of the tool palette. So if you're trying to look for those in the software, they're on the generic tab of the tool palette. Beyond these 3 sub-assemblies, though, you have additional tools that are available. So things like the link offset on a surface subassembly, it adds a surface link by specifying an offset location and a target surface. So the beginning of the link is the attachment point, and it's programmed to permit positive or negative offsets, and it can override a fixed width by targeting an alignment. Now the next 2 are very similar, the link to marked point and link to marked point 2. These subassemblies enable you to connect a link from the attached point to a previously marked named point. The beginning of the link is the attachment point, and it can go in any direction. The direction is determined by the location of the marked point, or the named marked point. And that can be on an adjacent corridor model if you want it. The difference between the marked point and the marked point 2 subassembly is that the marked point is on a different assembly baseline compared to the link, and the baselines do not need to be parallel. So that's the only difference there. Now the next one that I'll talk about is a daylight subassembly. So the first one is our daylight general. I'm sure that you guys have probably used this one before if you've done any kind of road design. The parameters on it can include up to 8 different cut slopes. Each of those cut slopes can be assigned their own material. So one could have riprap and another could have, let's say, grass if you want it. You do not have to use all 8 parameters, though. So if you only need one slope, you can leave all of the other cut slope parameters and the slope parameters, the slope width and the slope parameters set to 0. And that way, it only uses the ones that you actually set a width or a slope on. All right, the next one is the daylight max. And the slope used is determined by the maximum width permitted. So if the daylight link can touch the target surface within the maximum width parameter set, the slope is defined by the slope parameter. However, if the daylight link cannot touch the surface within the maximum parameter set, the slope parameter is ignored and the slope is defined by the width parameter and the difference in elevation from the hinge point and the target surface. Okay. Right to offset, and that subassembly creates a daylight link from the attached point to a step offset from the baseline. And this offset can be parallel to the baseline, or it can even target an alignment, a polyline, a feature line, or a survey figure. And then, of course, different materials can be assigned to those links. The last one I'll mention is a daylight bench subassembly, and this creates repeating benches as needed at specified heights and widths, as well as slopes, until it finds a daylight to surface to. The cut benches can have different parameters than the fill benches if that's required. So let's actually take a look at this in the software. And again, these are already created, but if you have the time, definitely go through and take a look at them. All right, and just a little, hint or trick that I like to use when I'm creating assemblies for a specific corridor. I'll typically create those assemblies right next to the profile that I'm going to apply them to. So here's my pond outer rim profile, and when I scroll over here, you'll notice I only have one assembly that I'm using for that. And if I go in and I look at those assembly properties, here's my parameters. It's going to be a 4:1 slope for cut and fill for a maximum width of 25 feet. So that way, if it goes beyond the 25 feet, that slope that I've set here can be ignored. All right. The next one I want to look at is my North Bay. This one's really neat because I'm able to, with corridor models, you're able to combine assemblies and create even more complex grading. So, for instance, let me just go ahead and look at this assembly property. And that that down into your view. On the construction tab, you can see that I have a length, width, and slope, and then a link slope to elevation. So both of those sub-assemblies have been used, and combined together, it's going to give me the exact grading solution that I require for this project. Sorry about that, losing my earpiece again. All right, so that's how these have been created. Now, these two assemblies look the exact same. The only difference between them is the slopes that are set. So this one is a 45-degree slope, this one, or a 45% slope, this one's a 33% slope. And then on our south bay, we have a couple of different things going on. Here we've got a bench going, sub-assembly that's going to happen. And then we've just got some basic cut slopes, one at 45, one at 30, different slopes set there. Okay? All right. So last but not least is you're going to create the complex corridor. And when you're creating the corridor, you're going to use multiple baselines and regions for that corridor model so that you can assign all three of those alignments and profiles and assemblies into your solution, your grading solution. So just a little picture of that here. So basically, we had our outer rim alignment, right? We're going to apply certain assemblies to that are going to go out in this direction. It's going to daylight out to a target surface. Then we're going to grade the interior of the North Pond using this alignment. This is all one corridor model that you see here. So we have the North Bay alignment, the South Bay alignment, and then different assemblies or regions applied at different places. So in this area, you can see I have a benching solution or region. And in this area, I have I believe that one's my 30% slope, and this one's my 45% slope. So I can have all of these different regions, which are equal to assemblies, and the different baselines, which are equal to alignments, all combine in together to create one cohesive model. And then, of course, each region can target something different. So I can have, let's say, in this area right here, rather than targeting the surface, I can have it come out and target this polyline or feature line that's out here so that I have a nice slope going all the way to the edge of my parcel. So let's take a look at that, and this is where I'm going to spend the majority of my time. How am I doing on time? I should check real quick. Okay, we're still good. So this is where I'm going to spend the rest of the time is actually building that corridor model. So I have my grading, or my alignments, my profiles, and my assemblies all created. I'm ready to combine them together into one solution. And I'm going to do it step by step. For those of you that have not worked with baselines before, I'm going to step one baseline at a time and let you look at it so that you can see what it looks like. So on my Create Design panel at the Home tab, I'll choose to create a corridor, and this will be my pond corridor. The alignment that I'm going to start with is going to be the pond outer rim, and then of course I need to choose the finished ground profile for it, and I'll choose my outer rim assembly. The target surface, I'm going to go ahead and have it target out to an existing ground. Now, you could have this target some other surface. It could be a combined surface from maybe another corridor and the existing ground surface that you've combined together to have a nice, easy solution. Now, I can have it allow me to go in and set the baseline and region parameters right away by making sure I check that. I'll just click OK. You can see it brings up this dialog box. We're going to come back and look at this in a little bit, but I wanted you to see that you can go ahead and add those baselines and regions immediately. I do have to rebuild the corridor, so I'm going to let that happen. And you can see it went ahead and just graded out from that pond outer rim alignment straight out to the surface. It's left the interior of my pond blank though. If I were to create a surface at this point, what I would end up with is just the slope, and then in this interior area, that would all just be flat, okay? Let me go ahead and grab that. When I select my corridor, many of you may be familiar with the corridor tab, or the contextual tab of the ribbon. And on that ribbon, you have a modified corridor panel. I'm going to add a baseline. It's going to ask me what alignment I want to add. So I'll add my North Bay. And immediately it's going to also ask me for the finish ground profile. So I'll select my finish ground profile for the North Bay and click OK. It doesn't look like anything happened, does it? Well, what's happened is it's added a baseline, but it has not added a region yet. So if I went in to show you the corridor properties, you can see here's my parameters tab. Here's the first baseline, which was my rim, and you can see it's actually showing it to you in the model. And then here's my region that's gone all the way around. But then here's my North Bay, and there's no region underneath it. Well, I can add it through the Modify Regions panel, or I can right-click inside of this dialog box and tell it to add a region. It's going to ask me for the assembly, so I'll choose one. And this is my North Bay, so I'll start with 40%. Now, you'll notice that it's going from the start station all the way through the ending station for this. So when I apply it and I rebuild that corridor model, get rid of this advanced view. I'm going to just put it on the other screen so it stays out of our way. All right, so you can see it's gone in and it hasn't found daylight. I did not set a target for that. And that's okay because the assembly is already going up to a specific elevation, so it was fine. When I go back into that corridor parameters, though, I can change where that ending station ends for that region. So if I want to, I can go and select the option to set it to this point and rebuild my corridor there. So you can see I can add regions, I can shorten regions. If I wanted to add additional regions, I can come in and on the Modify panel, I'll choose to add a region. There we go. It'll ask me to select the baseline. I'll start with my north rim, and I'll start at that endpoint and go to that endpoint. This one I'm going to use my double slope. Click OK. And again, my assembly already has the target elevation set, so I'm going to let it just take. Okay. You can see I'm leaving a gap in between these regions. And that's perfectly acceptable. What will happen is it will just interpolate between those two the solution that you need. And you can let the software do that. It's perfectly acceptable. And I'll go with a 33% slope. Click OK, and voila. So that's looking pretty good. I'm going to go ahead and jump over. You've seen how to add a baseline now. You've seen how to add a region. I'm going to jump over to one that has all my baselines and regions assigned. So you can see I've gone in and I have my my bench region here, a certain slope region, another slope. This is, I think, the 33% slope, and this one is a 45%, so that it creates all these transitions that I need. But I've left this area in the middle open. That's because I have these feature lines. Let me just show you this feature line. Edit the elevations of that. Okay. The feature lines already have elevations assigned to them, and we're ready to go ahead and move that into the surface. But before I can do that, of course, my corridor needs a surface. So I'm going to simply select my corridor model, right-click, and go into the surface properties, or I can click on corridor surface. It's going to bring up the corridor surface tab of the corridor parameters. I simply select to add a surface. I add my codes to my surface, and then I obviously would probably want to add a boundary as well. So I'm going to come over to the Boundaries tab, right-click, and choose the outer expense as my boundary. Rebuild that surface, or rebuild the corridor, I should say. Again, I'm going to get rid of that parameters there. And that looks pretty good, but let me show it to you in the object viewer. You can take a look at what's happening. This looks really nice. There's the benching happening here, a nice 45-degree slope, a 33% slope, but it's an area where I had this big gap happening. Well, I can take care of that, like I said, with feature lines, because I don't have to use the corridor to grade every aspect of it. Okay? So now I simply select my feature lines. And I would grab all of them to grab my rear and everything else. I'm not going to spend the time just clicking through that. So you're going to get the idea. And then over here on the in the tool space, I'll expand my surface. And here's my pond surface that I'm going to be working with. If I expand the definition, I can right-click on the break lines, add those, and this will be my weir. Click OK, and it cleaned up that area where I had grabbed just those three little lines. You can take a look at this. There we go. That's with the weir, all of the feature lines selected. The weir is looking good. And when I go into the object viewer, now I have a nice little 2-bay pond for my lagoon with the weir in between. Okay? But unfortunately, gosh darn, what ends up happening? I had a design change. If this were done with grading objects, changing that would be very, very difficult. So, you know, especially if I had a complex grading object where I graded one object off of another, I couldn't just go in and modify the feature line that one grading object created. However, I can make quick modifications to the corridor model. So, for instance, let's say I want to go in and change this area. Maybe I need just a section of it extended out. If I select that corridor, I can split my region. I can say, well, I need to split. Whoops, I didn't grab it. There we go. Now it grabbed it. So I can grab this region right here to right here. Oops. It looks like it split correctly. Let me extend those out. And by the way, if I'm group editing, the triangle is going to allow me to change one area at a time. Might not be zoomed in enough here. There we go. There we go. You can see it split my region, gave me a little bit of a gap. I don't need that big of a gap. So I'm just going to, doesn't want to take here. There we go. All right. But I want to change out this region. Well, it's not a problem. I can come back up and modify my region and actually change out my my region. I can go into the properties. I can change out the properties of it. So if I wanted to actually match the properties of this region to this region, I can just say match the properties. It's going to ask me for the source region. I select it. And the destination, I select that region. Did not take. Oh, it's because I have two different. So if I wanted to match the properties, but the assemblies used need to be identical, and then you can change the parameters of those assemblies, okay? So the other thing you can do is you can actually go into the section editor. So if I click on the section editor in my contextual tab, it will bring up my assemblies. And I have to look and see what, there we go. Let's jump down to this assembly. So I can actually come in and look at the parameter editor, and you can see that I have my daylight max width. Where did you go? Problem with having so many windows. Let me try that again. Let me see if I can get it to turn back on. doesn't want to come on with all of those extra windows with the WebEx going. So apologize. But definitely you can go in and change those parameters. I'm sure you guys have done that before. I can change out assemblies. I can do whatever I want. In the end, what we'll end up with is something looking about like this, where I have it extending out. Maybe maybe this is a ramp going into the pond for some reason. So that's easy to go ahead and take care of by changing out those parameters. All right. So we've looked at creating a very complex corridor model. We've looked at modifying it. So we've modified the grading solution by changing either the alignment, the profile, the assemblies, or the target, whatever you want to do. And of course, we've done it through the Modify Region panel. We've done it through the Modify Corridor panel. And we've worked with the Modify Corridor section. So the Modify Corridor panel, in that panel, the corridor, the tools are required to make changes to the entire corridor model. So that's the Modify Corridor. The Modify Region panel is just one region at a time. What assembly do you want to this one little section? Okay. So we've already gone through and modified that. So in conclusion, what we've done today is we've created alignments that can be used for a grading solution rather than a road design. We've created profiles that are used for grading solutions. We've determined the best sub-assemblies to use for the type of grading being created. We've looked at a number of different options. There are a lot more options out there. I've just picked just a fraction of what's available to you. So definitely go and take a look at that. If you ever have a question about what assembly to use, let me just show you this little tip here. I'm going to open up my tool palette. There it is. If you ever question what assembly I should use, if I wanted to work with shoulders, I could right-click on that shoulder and go into Help, and it's going to bring up a help system that will tell me about that assembly. So it tells me what it looks like, what parameters I can set, where I can attach it, the default options that are there, how you can override them. And then it also goes down and tells you what your target parameters could be, your output parameters, and the behavior of it. And then last but not least, it shows you all the point codes, and those point codes are what's used to actually create that finished round surface. So definitely, spend some time getting to know your tool palettes, getting to know your sub-assemblies within your tool palette, because once you get to know that, the sky's the limit. You can do whatever you want to your grading. All right, so getting back, so we've determined the sub-assembly. We've created a corridor model with multiple baselines, regions, and we've added the multiple alignments and profiles and assemblies to that. And then we modified the grading solution by changing the alignment, the profile, the assembly, or the target surface. So that concludes the presentation. Just to give you an idea of what's available to you, though, we do have a number of books that you might want to take a look at if you're not just doing grading inside of Civil 3D. You might want to look at the survey book or the fundamentals, which gives you a good overall picture of what you can do in the software. We also have our infrastructure design suite. If you're doing a lot of road design, it gives you the option to start a design inside of InfraWorks and then take that design right over to Civil 3D and not lose anything in the process. So great book to look at. The other is InfraWorks Fundamentals. If you'd like to really learn how to get really high impact visuals immediately, InfraWorks is a great solution, and we do have a fundamentals book on that. We've got the Map 3D Essentials Guide and a plant design guide as well. All of our books come in multiple formats. We have the printed spiral-bound book so that it lays flat on the desk. We have the e-book, which is my favorite. Everything fits right inside of my little iPhone or my iPad or whatever. I can take it on up to 2 different devices, so I can have it on my iPad and I can have it on my home computer as well. We do have e-learning bundles available. that bundle together the fundamentals guide, I believe it's the survey guide, and the BIM workflow guide. Karine might have to correct me on this one. I think even the Map 3D might be included in that bundle as well. And then, of course, we have instructor tools. The PowerPoints that I've used today, those come from our instructor tools. The instructor tools give you the outline of how long each day of the course should take, how long different exercises should take. It also gives you answers to all of the questions at the end of each chapter to make sure that you're learning what it is you're intending to learn. And then, of course, we do include the slides there that you can teach from if you are actually teaching the course.
Hi, Michelle. I can just pop in and let everyone know that for the e-learning bundle, it includes Civil 3D Fundamentals, Civil 3D for Surveyors, Civil 3D Grading, and InfraWorks Fundamentals.
Okay, that's what it was. Excellent. Thank you, Karine. So if you have any feedback for us, definitely send it to us through this email that you see on the screen, the feedback@ascented.com. If you'd like to take a look at the books and purchase any of them, you do have the ASCENT e-store there. So at this time, Karine, do you want to go ahead and open it up to questions and answers?
I will. I'll do that in just a moment. I just wanted to make sure as well on this screen that people notice we do have a Twitter account, so please do follow us on Twitter. I post all of the new courseware updates on there, and we also sometimes run promos and flash sales. And if we do the flash sales, we do them through Twitter only, so if you are not receiving any discounts on the books, do keep an eye out for those, because we'll run those occasionally. And also, I would like to encourage everyone, too, to follow our blog, because all of our authors do put blog posts up there, of course, including Michelle, and so it would be great if everyone could follow her as well.